Let me take you on a journey to the coldest place on Earth and its last and greatest wilderness, on a voyage to Antarctica. Hello and welcome back to A Voyage to Antarctica, brought to you by the UK Antarctic Heritage Trust. I'm Alok Jha. If I asked you to picture a penguin, I bet that the image which would immediately come to mind is of Antarctica's most iconic resident, the emperor penguin. Here to tell me all about these extraordinary birds and the threats that they're currently facing is Dr Peter Fretwell, award-winning cartographer and leading scientist at the British Antarctic Survey. Peter pioneered the use of satellite imagery to find and monitor polar wildlife, a project that led him to discover almost half of the world's emperor penguin colonies. He chairs the Scientific Committee on Antarctic Research and heads up British Antarctic Survey's Wildlife from Space group. He's also completed 5 field seasons in Antarctica. He lives near Cambridge with his wife and family. Peter, just describe for us what emperor penguins look like, and can you tell us where we'd normally find them on Antarctica?
So emperor penguins are a fantastic animal. You know, as a scientist, I'm not really supposed to have favourite animals, but I must be a bad scientist because I really like emperor penguins.
I think you're allowed to have a favourite animal. It's okay.
So, yeah, they're the largest of the penguin species, up to about 4 feet tall, 1.2 metres or so. And they can weigh up to about 40 kilograms, which is very heavy. Typically, an emperor penguin is almost twice as tall as some of the other penguin species. If you look at an emperor penguin compared to, say, an Adelie penguin, it's got more colour in it, it's got a much larger beak, it's somewhat fatter as well, they're one of the fatter species. They don't run, the small penguins waddle with their flippers outstretched. The emperors do things much more slowly. They'll have their flippers by their sides and they'll just slowly almost sway in a swaying type of walk. They have to conserve their energy because they often have to walk long distances over the ice. And often they're actually moving on their bellies as well. So they're black on the back and white on the belly because if a predator sees them from underneath, it's white, so it looks like the sky under the water. If a predator looks at them from above, then they're black and they look like the ocean. So that's why they're white on one side and black on the other.
They're the ones you probably think of when you think of majestic penguins, especially in TV documentaries. They're the ones on the front covers of magazines and books, aren't they? They're the most famous of the penguins, I would guess.
I think so. They're often mistaken actually for king penguins because they do, on a photo, look very similar. The real distinctive difference is that the cheek flash, as we call it, on the emperor penguin just fades into pale white, whereas it's solid and more orange on a king penguin. Even people who think they know penguins can mistake the two species. They breed further south than any other penguin species, really around the very southern coastline of Antarctica. And they have this really weird breeding pattern of breeding in the Antarctic winter. And that's because they don't actually come out onto the land at all. They breed on the frozen sea, the sea ice, the fast ice, which sort of attaches to the land in the Antarctic winter. And they use that as a breeding platform because it means that they don't have to get up the ice cliffs which surround most of the rest of Antarctica. So they breed in the winter when the ice forms, and in the summer, when it all melts away, the chicks fledge and they disappear and go back into the sea.
The chicks are hatched, and then how long do they have to survive? How many winters do they have to go through before they can then reproduce if all conditions go well?
So typically, adult emperor penguins, they will come back to their breeding sites in about April time, which is the Antarctic autumn, the fall. It's getting colder then, the sea ice is starting to form. They go through their courtship, they lay an egg, only ever one egg, in about June time. After about 6 weeks or so, the egg hatches. And one of the interesting things there, it's the male which incubates the egg. After the female's laid, it passes the egg to the male, and it has a little pouch over its feet. So the male stays in these huddles in the darkness and cold of the Antarctic winter, and the female goes off to forage and get back its energy in the Southern Ocean. And then when the chick hatches, if all goes well, the female will come back just about the same time to give it its first food. And that's usually about late July, early August time. Over the next few months, the chick grows rapidly and the adults take it in turns until about October, when the chick is usually big enough to fend for itself, and then often we get both adults going out into the Southern Ocean to forage, and the chicks crash together, often forming small groups. And then in about December time, or mid-December, the chicks will lose their fluffy, downy feathers that you see on happy feet, and they'll get these sleek, waterproof feathers that you see, the black and white ones we see that the adults have. They're waterproof, and then they can go into the water and forage for themselves. So that's the sort of annual life cycle of the emperor penguin.
Peter, tell me how these animals, emperor penguins and other penguins actually, are adapted to living in such harsh conditions on Antarctica.
It's such an extreme environment that they have many unique traits and adaptations to help them through. If you think of an emperor penguin, the temperature in the winter where they're living can get down to -50 or even -60. And it's got those really strong, sometimes hurricane force winds, total darkness. So yeah, they have to be really, really specialised. The emperor penguin has got the warmest feathers of any bird in existence. It's the deepest diving bird. We've had emperor penguins recorded to dive down to 650 metres below the ice. To do that, it's got the largest bi-ratio chest muscles of any animal. But it's the cold adaptations which really are quite startling. It's got special irises that keep out the ultraviolet light, which we actually see on several species of penguins. And of course, there's behavioural traits as well, like huddling. There's a whole raft of really quite unique adaptations that they have to be able to withstand the environment they're in. But they've evolved for that, and that's where they're happiest. If you make it too warm for an emperor penguin, it will overheat once it gets to about 0 degrees. So it really does have to be quite cold.
I suppose there's pluses and minuses for being so well adapted to the cold, but I love the idea that they've got the warmest feathers as well. Can you paint us a picture of how you got to where you are now? Was it the wildlife that interested you first?
I've been working now at British Antarctic Survey for over 20 years, and I actually started as a cartographer, mapping the ice and the coastlines around Antarctica. And we used a lot of satellite imagery nowadays for that because it's very hard to get to these places. So I started really developing a skill set with remote sensing, as we call it, so the study of satellite imagery and how we can use that to map and study the world. So I got into the wildlife through the remote sensing, the satellite imagery. And in about 2009 or so, while I was actually doing some mapping of the coastline for our pilots, I noticed we could see these strange brown stains on the ice around the coast. And I'd been working with some of the biologists, and I said, I think I can see penguin colonies. These strange brown stains, they seem to be penguin colonies. And we found they were penguin colonies, emperor penguin colonies, and we started this journey to really look and study emperor penguins by satellite.
So, Peter, before people were measuring penguin colonies using the technology you have helped develop, how did they monitor penguin colonies? How do you count penguins before satellite imagery came along?
Well, you had to go there, really. And as we know, Antarctica is harsh, cold, dark, and massive. It's twice the size of Australia. For things like emperor penguins, which breed in the Antarctic winter, it was particularly difficult because people don't like going in the really harshest conditions, and mostly we go in the Antarctic summer. And by that time, usually the emperor penguins have left. There are many places around the coastline of Antarctica where we just hadn't ever gone to at the right time of year. You need an icebreaker, and even then, even with the best icebreaker in the world, often you can't get to some of the places where you need to get to. So it's really hard to get to these places. So many of those coastlines were unsurveyed.
And so that's interesting. So I suppose zoologists who wanted to understand life at the coasts of Antarctica had these really quite challenging, physically challenging tasks to go there, count things, and then try and stay for as long as possible to work out what the life cycles were. So being able to monitor this from space, at least in some part, must have been a godsend at the time. How was it responded to by people in the field?
Well, yes, for many things, not just emperor penguins, but for other species as well, the seals that live on the ice and even whales and albatross that live in really remote places. It really has been a godsend. It's changed the way that we study them, but also we can scale up with satellites because we can go anywhere at any time of year, on any day, and we can get an image. I can sit here and within a few hours I can get an image of Antarctica, sometimes for free, sometimes for a few £100, depending on the resolution we want, where it would cost months of planning and then the cost of a ship to get there, people. And also it's very dangerous to get to some of these places as well. There have been many instances of disasters which have happened with people going to study penguins. So it's not quite as fun and romantic when you're sitting in your office counting penguins, but it is certainly safer.
And I suppose you get much more data and you can monitor the populations over a much longer period, as you say, in the Antarctic winter. You said you trained as a cartographer and you've been working at the British Antarctic Survey for a long time, mapping the continent, which in itself is a grand challenge that's not completed, I'm sure. But when did emperor penguins enter your life as a professional?
I'd seen March of the Penguins, and working at the British Antarctic Survey, you obviously have this relationship with Antarctica and its wildlife. And I'd just come back from a season south, and I'd seen one emperor penguin, which was a bit of a vagrant on the South Shetland Islands. So I didn't know a great deal about emperor penguins, and it was that light bulb moment of seeing them on the ice where suddenly my career changed really from that moment on. We went on not just to find emperor penguin colonies, but to also count them using higher resolution imagery. So now we've actually doubled the number of colonies that we knew about before. Half of those have been found by satellite, and most of the ones that have been found by satellite have never been visited by humans.
Now, in terms of how you monitor them from space, then talk me through the process. We've talked about how you can sort of take pictures at different resolutions from space. What is the process of getting those pictures? What satellites are you using? And then how often are you taking the pictures and how are you using it to monitor these populations?
So at the moment, we're using a combination of what we call medium resolution and high resolution satellites. The medium resolution satellites are free and are taking imagery all the time of everywhere around the world. So anybody can go and download those for free. They're taken every few days. And we use those to locate where the penguin colonies are. And then when we find them, we task the very high resolution satellites to go and take an image. Now, these satellites are so high resolution, they don't take imagery all the time. They just only take it if you ask for it and pay for it, basically. So we can then look for a small area which we will capture once we know the exact location of the colony. And that's at such a high resolution, we can see each individual emperor penguin when they're not clustered together. And at the moment, we're counting them individually and we're working on automated routines to do that for us.
Yeah, I mean, it sounds like a job for a machine to be able to count these things, but I guess it must be difficult to tell the difference between, a massive black spots and one big black spot. How do you try and get a machine to learn the differences between individual penguins like this? What's the sort of challenge?
So machine learning is sort of as it sounds. What you do is you train the machine, you tell it what one penguin looks like, what another penguin looks like. You give it lots and lots of examples of different ways that something might look. We've got these projects now going on for a number of different species, albatross, whales, seals, as well as penguins. And it's all about getting the training data. And often you need thousands and thousands of instances of the training data to successfully train the machine.
Do you have to supervise that? Do you have to tell it what's in the training data?
Yes, so a human usually has to go and put a dot around a penguin or put a box around a whale or something like that. So when you're doing your security checks on your camera and saying what a road looks like or this is a sign, that's what you're doing. You're feeding into machine learning algorithms for road safety and things like that. We don't have those, but we often will get students or other people to help in this. And often, because we're never entirely sure, we have to get multiple people to give an assessment of what a penguin looks like or what a whale looks like so that we can sort of get an overall confidence, because one counter makes mistakes. And the great thing about computers is if you can get an average over lots of counters, it will then never make a mistake. It will always get an average of what those people show.
So, I mean, if you've got to sort of tag thousands, maybe tens of thousands of pictures, each one with a varying number of animals that may be blurry spots on them, that's a huge amount of human work as well, isn't it? That could just be doing other science, I guess. So how do you balance that versus training a model that will be able to hopefully automate the whole thing in the future?
It depends upon the behaviour. The more diverse the behaviour, the more training data you're going to need. So a small black dot usually always looks like a small black dot, so we don't need many training data for that. But if you take a humpback whale, which is often, you just see the splashes, you can see its tail, you can see its fins sometimes or not, then that's got quite diverse behaviour. You need more, you need thousands of different instances there. But overall, when you've got that data, then that will work forever. And we can run that into a model and we can expand out then to thousands of square kilometres.
And I suppose also the satellites are going to get better.
Absolutely. For the visible satellites that we're using at the moment, there are plans to launch about 30. Then there are other technologies as well, like synthetic aperture radar satellites, which can look through cloud or look through even darkness. So we've just got the first winter image of an emperor penguin colony where the radar can actually look at the penguins and count them in the polar night. So that's another advance. And of course, the other thing is the systems, the pipelines that we've got are getting better all the time. So we've got plans working with our colleagues in America and Canada with northern right whales, which are critically endangered, to start a system out where we have an almost real-time system where we can find the whales and count the whales, and then that's done automatically using AI and satellite imagery, and alerts the Coast Guard when we spot these whales, and then the Coast Guard can tell ships in the area to avoid that area because there are whales there. So that's the sort of applications we're looking for in the future, where we can join AI, satellite imagery, and these really quick pipelines so that they can help with conservation on an almost real-time basis.
Something that struck me from your work, which was published in 2023, was a study you had in Nature Communications on emperor penguin colonies in the spring before. And it made for very uncomfortable reading in terms of what's happening to those penguins down there. Just take me through what you found.
We've been looking at emperor penguins now for almost 15 years. We count the whole population of emperor penguins every year now by satellites. And to do that, we have to look where the penguins are. Last year, when we started to find where the penguins were around the continent, we saw that in certain places, the sea ice, which should be there, was either not there or was starting to disintegrate really early in the season. This is terrible for the penguins because if the chicks are still on the ice and haven't got their waterproof feathers when the ice melts or it breaks up, then the chicks go into the water. And if they go into the water, they either drown because they can't get back on the ice, or they freeze to death even if they do get back on the ice because their feathers aren't waterproof. So for many places, we found that we were seeing this pattern of sea ice loss right underneath the emperor penguin colonies, leading to what we assume to be total breeding failure that year. All the chicks will have died.
All of the chicks died?
We think so. At many of the colonies around Antarctica, I think we counted 19 where it had affected the colony to some extent. Probably about 13 of those, all or almost all of the chicks died at. That's the first year this has happened to this extent. We sometimes get one or two colonies where the ice breaks up early, but to have it happening over almost 20 colonies was unprecedented. And that was linked to the really, really low sea ice levels last year. Unfortunately, this year is looking even worse than last year in certain areas. And of course, if this continues, it will drive the population down. It's sad for a year. For a year, they could probably deal with, but as it continues, then we're really going to start seeing those populations plummet.
Just picking up on a couple of those points, I mean, you said that in your paper, you found that in nearly all of the colonies, all of the chicks had died. There was no children, essentially. I just wonder how it can get worse than that. I mean, what does it say about the colonies if no chicks at all survive? How many times can that happen before, as you say, the actual overall population starts to diminish?
Well, that was 19 out of about 60 plus colonies. So we had almost a third of the colonies affected. They probably can withstand a year of bad breeding. It sometimes does happen. But if you get multiple years, how many years is difficult to say, because there are other drivers of population change linked to climate change as well. Things like the lack of krill. Krill breed under sea ice. If there's less sea ice, there's less krill. Warming temperatures means rainfall, which is also bad for the chicks. So there's a real sort of mix of bad things that can happen to a penguin that is really adapted to live in these really cold environments. If those cold environments don't exist, then it loses its evolutionary niche. And if it loses its evolutionary niche, it won't survive for very long.
And I suppose the penguins can't exactly migrate to somewhere colder because they need the coastline. They need the water nearby to sort of get their food for themselves and their chicks. If the coastlines themselves are warming up, then that's it for them.
Absolutely. So if you think of Antarctica, it's almost circular. You can't go any further south for an emperor penguin because you just hit the coastline. There are a couple of indentations there in the Ross Sea and the Weddell Sea, which we think may last for longer. These we call refugia. We think that's where the best chance for the emperor penguin will be in future decades. But our models of what's going to happen to emperor penguins are quite pessimistic, unfortunately. We see the population declining rapidly over the next few decades until by the end of the century, in 75 or so years, there'll be virtually none left. So it's not good. And we know that climate change now, it's sort of baked in for at least a couple of decades. It's just a matter of how long it takes to turn that around and whether that's in time for this species.
No emperor penguins within 75 years. I mean, that's just heartbreaking. That's like a couple of generations from now. I think that people might have heard about the impacts of climate change in various parts of the world, and especially in Antarctica, given that it's one of the most pristine environments left on Earth. The fact that there's such devastating impacts going on right now there is surprising. I wonder for you, as scientists who monitor this area quite a lot and know a lot about the zoology of that area, did the paper you published in 2023 about the penguins, did it surprise you, the scale of it?
Yeah, I think 2022 and 2023 have both been really worrisome. We've seen a change over the last 2 or 3 years, certainly with the sea ice. Up until about 2016, we were predicting that sea ice would decline, but it was actually rising slightly. We couldn't really understand why it was rising. And then suddenly the numbers went off a cliff. And that's been accelerated over the last 2 years, so that we've got levels of sea ice way, way below what we'd expect. And one of the problems is the fact that we're finding it hard to predict what's going to happen next. Our models really aren't predicting these sudden shifts in the system. And from a scientist's point of view, that's really worrying, because if you don't understand the system at the moment, how can you predict what's going to happen in the future? 2022 was the first year where I've talked with a lot of scientists, and there's a sense of not just urgency, but real worry that we don't understand some of the systems as well as we should, which means that we can't predict what's going to happen. And that's really the first year that we've really seen that.
Hello, I'm Camilla Nichol, the Chief Executive of the UK Antarctic Heritage Trust. As a charity, we work to preserve and protect Antarctica's unique heritage. From the wreck of Shackleton's Endurance and the historic huts of the early pioneers to the amazing discoveries in climate science. Our mission is to inspire more people to discover, value and protect this precious wilderness. If you enjoy what you hear today, please do consider supporting us. You can share this podcast with others, or you could visit our website to make a donation. You can play a part in Antarctica's future by making a gift towards our conservation efforts. Visit ukaht.org or search for the UK Antarctic Heritage Trust. Thank you and enjoy the rest of the show.
What if your favourite beach was surrounded by icebergs? What if you could go paddling in 0 degrees? What if the crowds were part of the charm? Search Hurtigruten Expeditions and find cruises to Antarctica and more. HX, change the way you see the world.
What other patterns are you seeing in the distributions of animals around Antarctica and on Antarctica, as well as what you just told us about emperor penguins? Are there other animals that you're monitoring, that you're concerned about, that you're kind of interested in the area?
Yes, but it's not all concern and bad news. The animals that are dependent upon the sea ice, like crab-eater seals and possibly minke whales and the Adelie penguins, they're not going to be doing too well at the moment. And we're monitoring some of those. We've got projects monitoring crab-eater seals, which will also be affected. But for some species, it's good news. It opens up habitat that wasn't available before. So on the Weddell Sea, for instance, where we've lost many of the ice shelves, we're seeing new species moving in. Whale species, seal species, other penguin species, which traditionally would have bred further to the north. And they're starting to exploit those habitats. I was in the Weddell Sea last year and I saw over 100 orca and many humpback and other species of whale that we just have got no idea were there before, because they've moved into those habitats where we've lost ice.
Now, penguins have always held a sort of fascination for Antarctic explorers, haven't they? I mean, even the heroic age where you had these memorable stories of explorers like Apsley Cherry Garrard. His accounting of the ill-fated search for emperor penguin eggs at Cape Crozier, for example, is kind of legendary. Do you see your work and your sort of love for them as part of a continuum that stretches back to those initial heroic explorers that were fascinated by these birds?
Absolutely, especially the finding of the colonies, because many of those early colonies were found by the early explorers, from Scott to Larsen and Mawson and all of those great names of Antarctic exploration. They were all very important in the finding of emperor penguin colonies and other penguins as well, because they are so hard to find and you have to overwinter basically to find them. So Now we've gone through an era where we were doing survey by planes and ships. Now we're using satellites. So yes, it's definitely a continuum. I think we've found just about all of them now. I've learned from experience never to say never, that we'll find
you never
colonies. And especially now as they're having to move. In many cases, with sea ice change and loss of sea ice, the colonies are moving. In 2023, we found that many of the colonies have had to move 20 or 30 or 40 kilometres to find safer ice. And that's something that we're going to have to continue tracking every year now as the penguins try and adapt and try and find safer environments. We're going to be seeing them moving more often.
We've talked about how you monitor these animals from space and the ways that that's improving. But of course, it's still important to visit, because you do need to ground truth everything in science. You can't just believe everything you see from satellite pictures, although as useful as that is. And you yourself have been to Antarctica 5 times. I'm just curious to learn a bit more about what your impressions are. You know, you've obviously been working around the topic of Antarctica for so long. What do you sort of feel when you go there?
It's such a unique place. It's such a privilege to be able to go, actually. We forget as scientists, I think. It still really excites me to go and to see these landscapes that are like nowhere else on Earth. I'm lucky to go to places that even few scientists get to go and see. We do see change as well. I remember I went first to James Ross Island and the Weddell Sea in 2006, and I went back in 2022, and you could see massive change. What was once a pristine environment of white snow-capped peaks now is dirty ice, because the ice has started to melt and ablate, and it's leaving a lot of dust and debris on the ice, which wasn't there before. So we think of Antarctica as a pristine environment, but around the edges now it's starting to look much less pristine as we see the ice melting. So that really does hit home when you can see these places and you go and you see the change over the years.
Yeah, I was going to ask you about the environmental changes you've seen. You've talked about some of them just now, but is it really clear that the environmental changes we're tracking from space and in the other parts of the world are really coming for parts of Antarctica? When you go there, do you see it? Does the ice crumble underneath your feet?
I wouldn't say the ice crumbles beneath your feet, but certainly we see changes. Some of them are slightly more subtle than that because there is so much ice there. But in the places I go on the Antarctic Peninsula, absolutely, it's very visible. And it's, as well as the ice itself, it's the animals. Our research station at Rothera, when I first went down 15 years ago, you wouldn't see elephant seals and fur seals or some of the shag colonies that we have now. And now dozens of them turn up every year. And they suddenly appeared a few years ago. And then the elephant seals, now there's 20 or 40 at Rothera. They're starting to breed near Rothera too. And the fur seals as well, they're starting to move down. There are Antarctic shag colonies which weren't there before. They've established themselves close by. So things are moving down the peninsula as we lose the sea ice and as the environment warms. We're even seeing it in vegetation and some of the snow algae as well. So yes, we're definitely seeing that as scientists if you've been there for any length of time.
As we said, a lot of your work involves analysing the images coming from space. But when you go to Antarctica, what are you doing there to sort of help the zoology part of the work you're doing? Is it specifically to do with improving the ways that you can monitor these colonies from space? Or is there more to it than that?
The latest field work I'm going on is to really calibrate the satellite imagery. So we've done this in walrus in the Arctic, but also we've done it on emperor penguins down in Antarctica, where because you're seeing small black dots on a satellite image, we're never quite sure how accurate counting those small black dots is. So we go down, we take drone imagery. So I'm flying drones over emperor penguin colonies to get really accurate counts of the penguins. We can't really differentiate between adults and chicks on the satellite images, so we have to make some assumptions. So getting the ground data really gives us a good idea of what we're really seeing in real life from the satellites, because it's never quite the same quality, even though it's really great and it's amazing. These satellites flying 600 or 700 kilometers above our heads can get this imagery. You can get much better with a drone that can see every flipper and every chick. So that's what we're doing. We're flying over the colonies, counting them, trying to get satellite imagery at the same time to calibrate the imagery. We also do other work as well. I work with the biologists. We're taking guano samples to look at DNA and what the emperor penguins eat so that we can see if they're in competition with fisheries and other species. And we're also putting tags on them, tracking their movements so that we can see whereabouts they're going and seeing if we need to protect some of the areas where they may be going. If they're foraging far away and have got conflicts with fisheries and things like that.
What are these creatures like when you get up close to them? I mean, I assume you don't get too close to them, but are they easy to work with, as it were, when you're collecting samples? And do they keep their distance? I mean, what are they like?
So we all think of penguins as penguins, but actually there are many species of penguins. The smaller ones, the bush-tailed penguins, the adelies and gentoos and chinstraps, they're very noisy, they're argumentative, they fight a lot between themselves. The emperors are much more sedate, much quieter, much serene, sort of imperial almost.
Hence the name, I guess.
to a certain extent, yes. They're quite slow and studied. They won't do anything in a hurry. So they're easier to work with in that respect. On the land, they don't have many predators, so they're not really that scared of you unless you make sudden movements. So they're lovely to be with, and they're such a fantastic animal to see and to work with as well.
Just a final question for you, Peter. Why does Antarctica matter to you?
Antarctica matters to me because it's both different, but it's also connected. It's so different to anywhere else on the planet. If you've been lucky enough to go to Antarctica and see this vast, harsh wilderness of ice that is untouched and pristine for the most part, and it's got nobody living there. So few people there, you can be hundreds of miles from the nearest other person. Just the penguins and skuas and other wildlife that you may see. So it's very different from elsewhere, but it's also connected because what happens in Antarctica often through the physical processes of the environment drives some of the climate and some of the heat balance around the world. So what happens in Antarctica, whether it be sea level change, changes to the world's oceans and how much heat the Earth absorbs, that really is connected to all of us. If we lose ice in Antarctica, it goes into the sea and raises sea levels globally. It doesn't just stay in Antarctica. So what happens in Antarctica doesn't stay in Antarctica. So it's important from those points of view. And to me, of course, from a personal point of view, it's totally changed my career and my life, really. So it's been a real personal journey, studying the unique animals and wildlife and environments of Antarctica. So it really does mean a lot to me.
That was fantastic. Peter, thank you very much for your time.
Thank you all. Lovely to talk to you.
Thank you for listening. A Voyage to Antarctica is brought to you by the UK Antarctic Heritage Trust and made possible by support from Hurtigruten Expeditions. To find out more about our guests and how you can support the Trust, please head to our website at www.ukaht.org or find us on social media. If you enjoyed this episode, please don't forget to follow and rate us wherever you get your podcasts. It makes a huge difference to us. Next time, I'll be talking to NASA astrobotanist Jess Bunchek about growing vegetables in Antarctica and beyond. A Voyage to Antarctica was presented by me, Alok Jha. Theme music is by Alec Hughes, and editing and additional music is by James Stickland. The show is produced by Jessica Norman. See you next time.